Well, hi, good morning. Thank you so much for joining me here in my shop. Today is, what is today? Today is January 13th. We're on the cusp of a lot of heavy, cold winter weather here, but that starts tomorrow, I think. So one more day of temperatures near zero, and then we're going down to the -10 range for 10 days or so, something like that. So there's a chance this is the first of my videos you've watched because it's a car radio. It's a little unusual for me. I seldom do car radios. I don't think there's an awful lot of tube car radios out there. Oh, maybe there are, in fact, because of people preserving older cars. So I don't, my experience with radios like this is very limited. And I don't know how this is going to go. This thing is a really big radio. I mean, it's gigantic. Look at the thing. And that's going to burn gas when you're out driving around. Buick. And then down here it says Sonomatic. S-O-N-O-M-A-T-I-C. Sonomatic. They liked the Matic back then. So we'll push these buttons. Pointer. I don't know if you can see that in the camera or not. Ooh, what's going on? Those buttons. Come on back. A little bit of lubrication lacking there. It's got the frequencies written here. Notice it has these spring clips here, which I'm guessing something gets pushed up against it, or it gets pushed up against part of the car with this protruding. And these, I don't know why they would actually have those there. Wouldn't want to rely on this for a ground connection. It's got to be a a solid like this sort of thing, a solid ground connection. This must be the antenna input, or this might be the antenna input. So this is the antenna input. What's going on here? I don't really know what this is. A big rubber or plastic piece around it. Here's a few words. Not many. Tune, 500 kilocycles, that can. Volume turned, full on. Something back and forth. So I know what this is. This was the alignment instructions here, which unfortunately they are mostly gone away now. So it's a big bolt up here. It's a big one here and a big one here. Washer, a lock washer, and this has been looks like this has been sanded a bit here. The whole thing has a funny look to it, doesn't it? It looks like, what it looks like is somebody took a paintbrush, maybe in the factory, and painted the metal with some kind of excuse me, some kind of coating, and that coating has come off. Either it just lost its adherence and fallen off to the point where you can see the brush strokes of the person who did it. Probably the new guy in the factory. He's going to spend a couple of months doing this. I thought I was going to make radios. Yeah. Okay. Got a metal grill here, but the speaker cone is right there. So you can imagine this is sitting in the car dash. Better to have the speaker this way. Than in most cars, the speaker was up in the top of the dashboard facing up, and that's a dust collector. Whereas this way it won't collect nearly as much dust. Okay, how do you power this? Where does the power go in? Where would you put in the power? So this is probably, we can consider this a ground terminal. There's no wire hanging out. Well, would it be this? Very good chance that this is the power in. And So hopefully, okay. So if this is one of the first times you've watched one of my videos, just a couple things I want to say before we go any further. First of all, I don't do much editing. You might be aware of that already. I don't do much editing at all. Just some rough transitions between shots. I just a touch of editing. So everything goes on video, including stupid things I do, stupid things I say, mistakes I make, and good stuff too. That happens along the way. And also, I'm not here to show you how to do this. You are going to watch me try to do it. That's really the dynamic here. I'm not trying to show my great skill and talent, because I would have a lot of trouble doing that. So, obviously we got to take this apart to some degree to figure out what's going on. This front panel has all this stuff, this front part here. So it's tempting to take these screws out, but I think I'm going to resist the temptation. If you look at the back part, it's really simple. There's nothing hanging off of it. What do we got? 1, 2, 3 screws. These are different kinds of screws, so I'm not the first person to fool around in here. Goodness knows a dozen people may have been into this radio over the years. Who knows? Can we turn it upside down here? Okay, I can see right away through the holes, the cooling holes. A couple of tubes right there. There's a serial number sticker on it. And what is the serial number? I can't quite read it here. And three screws here. These 3 screws, flip it over, the other 3 screws, the back's going to come off. Now, can I lay this forward? This thing looks like it's ready. This thing looks like you could put it into a tank. The way it's built, I probably put it forward without any trouble at all. Give me access to the back, where I can hang. Let's just do this. I'm sure that's okay. Let's take these screws off, and we'll find out what's inside. So a car radio, other than its form factor being very different from other radios, it amounts to the same thing inside. It's going to be a mixer tube, detector tube, probably 1 IF, 2 IF transformers probably, tube in between to amplify things, and some form of power output tube to drive the speaker. Now the thing is, tubes run with high voltage, high DC voltage. The minimum 90 volts or so, but typically in a bigger radio it can be up to 300 volts, maybe even more in some cases. But typically 250, 300 volts. How can this thing run in a car? And the car may be a 6-volt car. I don't even know if it's 6 volts or 12 volts yet. So how's that going to work? 6 volts is not going to make a vacuum tube operate. So there's a device inside these. It's kind of, if you don't know about it, it's kind of a dumb thing to hear about. They want to convert the DC into AC, run it through a transformer to boost up the voltage, and then convert it back to DC only at a high voltage. So how are you going to change the AC or the DC to AC? Well, today this is not a big problem, and it's done all the time. Back then, the best way they could come up with was to use a buzzer. They use a buzzer, which they now call a vibrator because they don't want to call it a buzzer, and the reed starts buzzing just based on the simple buzzer technique, and that reed can switch the voltage back and forth, and you can get a sort of a squarish alternating current out of it. You then just shape that a little bit. It's not too hard to do, and you get some kind of crappy sine wave out of it, and there you go. You just have to boost that with a transformer, rectify it, and you've got your high voltage. The vibrator is the most unreliable part in your entire car. I don't know about that. I don't know how long they lasted, but they did not last forever. That's for sure. So often, the first thing that someone would think with a car radio like this is the vibrator is pooched in it. And that's probably what's happened here. Now the owner told me what the problem, what his experience was with this. Wow, yeah, I feel like I'm lifting the entire radio. Why would that be? Let me try that again. I'm expecting this to just be like a light metal top, but when I go to lift it, it feels like it's lifting a ton here. Let me try again. So I'm looking at the relative motion of this versus the little piece inside there. I'm sure this is... oh, it's coming now. It's coming now down here. Yeah, so what you're watching is not, this is the 10th time I've done this exact model of radio. No, this is me just trying to figure it out. Trying not to do any damage while I figure it out. There we go. Aha, 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 aha. There are pins. Ha. Pins here. They're going into these holes, which is why I couldn't lift up this edge of it. Lucky me. Okay. Oh, more information. We have there's some tubes listed here. 6SA7, 6SR7. That's a little unusual. 6V6 2 output tubes and a 6SK7, 2 of those. So this may be actually a pretty good radio, considering that it seems to have a 6SK7 RF amplifier tube in it. Generally these guys have to produce a fair bit of power too, like a volume. Well, isn't that interesting? I see this. I'm not the first person in here. It's clean as a whistle. Look at that. Very clean. And look at that yellow capacitor there. Pretty sure that's a replacement. What else can we see? We can't see too many parts in here. Tubes. There's probably two 6V6 tubes right there that are doing the output. This will be the... oh! Well, we'll have to pull it. This is the vibrator I was talking about, which is a plug-in unit. It's interesting. It's got a little finger grip here and everything. Wow. This looks like a big capacitor. Could be a coil or transformer. Same thing here. This could be a capacitor or it could be a transformer. There's the two IF cans with slug tuning. So we have to have the access to the other side of these cans to tune this radio up. This is a adjustment probably for the antenna. It looks like the way they've got it arranged, it's meant to be accessed with the top on through a hole. I'm guessing they have this dish to help your screwdriver find its find a spot. Lots of braid in here. A couple more adjustments there. This would look like a light, maybe, down here through this tube. Probably a light. Wires themselves are not terribly stiff. Like I was saying, it's very clean looking inside. No, very nice. But it looks like we got to get the front off too. Either that or this whole thing has to come out of the box, which I don't think will happen because you can see the look at how this is done. These wires are strapped right into the cabinet here. This is soldered right onto the cabinet, so this isn't coming out relative to this. So I think really the other side has to come off. The other cover. That's the word for it. Cover. So I'm also kind of gambling here that I'm going to find a schematic for this radio, which is quite likely to happen. Wow. So I see now there's a cover here, which doesn't include all this. So you can take this part off. The speaker will probably come with it, and that'll probably reveal a lot inside. I see some screws here too. But these are probably holding the the chassis inside the can, and I probably should not be taking those off. At least not first. We'll try to take this top part off here. So there are a number of really good sites for finding schematics. I don't know about cars, but Pacific TV on the west coast of Canada has a great set of schematics, particular Canadian radio schematics. Was this radio built in Canada? I don't know. Good chance it was. Another one is Radio Museum. Great site to go to for information about radios. And one that maybe isn't quite so well known is Electrotania. Electrotania, I think it's a Russian site, to be honest with you. And what they do is they are collecting schematics of all kinds of newer stuff, not so much tube stuff, but say stuff through the 70s or 80s. So this is a soft foam here, and it's still soft. That's a little unusual. Usually by the time decades have gone by, these kinds of materials are failing. Anything that's soft, squishy, bendable doesn't survive well normally. All these screws are not all identical. In fact, there's quite a... Okay. Good luck putting them back in. Now, let's see. Get this to come up. Oh, two more screws. So our weather this winter has been really odd. It's been just warm, around 0, 1 degree, 2 degrees. Typically at this time of year a high would be -5, -10 even, but it's not. Snow we've had hardly any at all, although that's about to change. So it looks like you would lift this up and pull it back. That's what it looks like today. With the speaker and all. Peek in there. The speaker is soldered wires. I see some black electrical tape. It's exactly as I guessed. Nice long wires so you can do this. And can't quite get it. Put it down, put it down. The speaker looks to be in beautiful condition. Magnet will hold it. Get it. There we are. Magnet will hold it on. So here's this tube that I said might be a light, and here way down at the far end is the light bulb sticking out of there. What a strange arrangement. My guess is, I'm gonna take a guess, you can retract this light all the way out the tube. That seems crazy. And then you change the light and then you push it all back down this tube. That just seems crazy. I don't know. So here's the black electrical tape. So this did not happen on when they manufactured this radio, and this is not an original. This is a replacement for sure. And chances are this is a capacitor, by the way. The chances are this is shot. When I look inside here, I can see that someone has been in here and they changed all the paper capacitors. It looked like they did them all. They may have left this one in, but all these other yellow ones have been changed. Here's a ceramic one. May or may not have been changed. So someone's been at to work on this, and that's great. So chances are though this guy's not good. Okay, how do we power this guy up? How do we hook up the speaker? Well, the speaker's hooked up, and that's not even a question. How do we power it up? So where was that mysterious hole in the radio that something could be plugged in? It was okay. So we take this. I don't remember which way it went. Chances are It's right down under here. Okay, we're going to flip this guy up on his side. It's about the weirdest thing we encounter all the time in our lives now, and people have been wondering about it for hundreds and hundreds of years. Is magnetism. It's easy because it's been around all our lives. They just not think that hard about it, but that's just the weirdest thing, really. Okay, now, yeah, small things fascinate me. Let me just turn this up a little bit here. Okay, we wanted to look for where the power goes in. Here we are. So this would be the power in here, I think. This looks like the antenna for sure. This is the antenna connection. So what else could this be other than power? An external speaker. I don't think so. I don't think that was happening with cars at this day and age. This is the speaker here. This has got to be the power in. Does it actually say something on here that I missed? Little clips here to try to ground this cabinet. When you put it on to try to improve the grounding. If a cover like that were to be a little loose, electrically loose, like it might be mechanically, it might look pretty solid, but in fact electrically, because of rust and stuff, it's really not making very good contact. And as you drive along, bouncing down the road, the lid is going to chafe a little bit, just from the flexing of things, and that chafing causes variations in the electrical situation with the cover, and the result is you hear static coming out of the radio every time you hit a bump. So actually that's probably a huge challenge to the radio makers, to make this thing so it can tolerate being pounded on 1950s roads in 1950s cars without something coming loose. Not the least of which is the tubes themselves. Excuse me. Okay, I don't want to take any risks here, so even though I'm really pretty much 100% sure about this guy down here, I am going to look for the schematic and some reassurance that I've got it right. Otherwise, what am I doing? Sticking, and is it 6 volts or is it 12 volts? Is it 6 or is it 12? Well, I don't know what to say about this. The tubes are all 6-volt tubes. That's a suggestion that it's a 6-volt car, and these tubes would be powered with just DC through the heater. But that's not a guarantee at all. Yeah, I gotta find the schematic for this guy. And how would I do that? I mean, what, a Buick radio? That's about all I know about this thing. Buick, no, I know it's, oh, here we are. Buick Sonomatic radio, part number, what is this here? Part number 9800745. I mean, the whole radio has a part number, or this piece of paper has a part number. No, this is probably the number of the piece of paper down here. Printed in the USA. So that's a hint that this was built in the USA too. And for all I know, the car was built in the USA, driven around by an American for 20 years, and then somehow sold and moved up to Canada here where it is now. Who knows? The car's been around a long time. Cars have wheels, they travel. Who knows? Okay, I'm going to go take a little break, hunt down the schematic if I can, and we'll carry on from there. Well, it looks like I'm going to be lucky here. The Radio Museum seems to have the information I would need for this radio. I searched for Sonomatic, and the manufacturer I put in is Buick, and this is what came up. Certainly looks like the radio, that's for sure. And what do we got here? We've got a schematic, and we've got some instruction sheet here. Excellent. And we got some photographs down here. Does that look like the radio. Wow, look at that. It has the same little grip part here. I see there's a top. Oh, wait a minute. The IFs are in totally different positions here. Let me look at the radio again. Yeah, in this radio, the two IF coils are, yeah, this is quite different. This is totally different layout. They're right up in here. Yeah. So not exactly the same radio, but very similar. There was another one. Let's look at the other one here. So this is 1941. According to this, it's got 6K7 tubes. Now that tube would have a grid cap, and none of the tubes have grid caps on them in here. So I can't see that it's this one, but let's take a peek. Ooh, it's another one. It looks very much like this one. Wow, it really looks like this radio. Let's look at the layout here. So there they are. This, so let's see. So we have 3 tubes along here. I have 2 funny little discs down there. I don't see those. I think so this guy's there. In this picture, the vibrator's been extracted. We have this looks more like it. This looks more like it, but the tubes are different. So you know what that means? It means there's another version of this radio, where they went from the 6K7 double-ended tubes to these single-ended. This picture, wait a minute, this picture shows single-ended tubes. They have a 6K7 and a 6A7. Where are those appearing in here? They're not. Like there should be a grid cap on top of one of these tubes. 2 of them actually. And the rest are single-ended SK and SR7. Closer, but not quite right yet. Well, this one also has lots of information in it. A lot of information. Let's look at the schematic. Okay, so I'm going to just take a second. I'm going to download this. Well, here we can look at it this way right now. So 6 SA7, 6 SK7. So here they're suggesting, see right there, that's a grid cap. They're suggesting this tube is just a 6K7, but I'm sure in this radio, no. Could they possibly have converted the radio? I don't think so. Offhand. Interesting that they have both a 6K7 and a 6SK7. That's curious to me. Why wouldn't they have done an SK7 over here? Very curious to me. Down here we have 6K7 way up in this corner. Now is there a tube there and I've missed it? That tube is maybe I missed it. It's in a funny spot. It's off the 3. No, it's an S. It's a single-ended tube also. This one here. Voltage something between, yeah, something or other. Well, notice this too. IF peak at 260, not 455 like most radios. This one, the IF is tuned at 260 kilocycles. That's something worth noting right away. We have a lot of coil action here, coming into the first tube, and then we come out of the first tube and into another coil. It looks like a tuned coil. Come out of there, and the signal's fed up through the mixer tube, the oscillator coils. They haven't laid them out to make it easy to see here, because they've got the IF and other coils all in this row that the way they've drawn this diagram. So this is in a can, this is in a can. These two must be the IF transformers, and this is probably the oscillator, part of the local oscillator system in here. Look at what's all this stuff. Whoa! Looks like some filtering there. There's the vibrator there. Hey, how's the power get in? It is right here, just on this piece of wire. It's just, they're not making it easy for me. Wouldn't the power want to go straight to an on-off switch like this? This is probably the on-off switch. Oh boy, oh boy. Yeah, my familiarity with these circuits is limited. I mean, I have an overview of them, but I don't know in detail, why do they have certain parts. But wow, and one thing I've noticed about these car radios is they are loaded with filters. Like this. I believe this to be a filter. That looks like a fuse there. A lead connector. A lead connector. Tube socket voltages. That's another diagram, I guess. Well, I'm not sure. I'm not sure I can go forward with this exactly. Probably, even though the part arrangement's a little different. Thinking about the alignment procedure is probably the same as this radio. Ay. So, what I really want to do though is put some power into this radio and try turning it on. So we're back to, where does the power go in? Well, there's not many options on this radio. There's only two input spots. One is clearly the antenna, I can tell from the connector, and the other one, it must be the positive connector. Okay, let's look back in the radio here. So what would I do if I wanted to arrange a plug to power this radio? Where's the plugs go again? Right here and here. Clearly this one is the antenna. What's going on with this one? Now on the cabinet they have this protector here. Can you picture somebody with a plug? I'll pretend this is the plug, reaching underneath the dash and going, this is positive from the car battery, going to put it in there. And if they do that, well, unless they've disconnected the car battery, which would be a very good idea in this case, pow, big pow. So they're trying to make it easy for you to get the power in without bumping up against the cabinet. So they've covered this entire great big grommet here so you can't short it out on the way to sticking it into here. This has to be the way in. There's no other place for power to go. These terminals out here, these have to be just for holding the radio in place, bolting it into the cabinet. These are powerful bolts here. Okay, now they don't really have anything that can shove in there, but this is going to draw off everybody. Oh, what's the voltage? Jim, can we find the voltage? Oh, let's go back and look at that schematic some more. Okay, so say the voltage anywhere. Let me zoom in here a bit. Would the vibrator have something written on it that gives a hint? What's that say there? Clutch coil. Through the light. Well, you close this switch and the light comes on. That's it. Well, what? Hey, maybe there is a dash light control. And this looks A-lead connector. Is this what's sticking out the back of the radio here? And then what is this? This is the, I don't know what this is. What is that? This looks, so this is the edge of the cabinet, and then this is the big connector we're looking at with the grommet around it. And you come in and you meet up with this is probably a fuse. And then we have a capacitor, probably trying to get rid of ignition noise right away. And then we have the switch, which would switch the power onto here, switch the power through the light. Coil. I don't know. I don't know what this is. That's what's going on. This is the input. Now, come on, show me a voltage. Somebody, anybody, maybe in the information on Radio Museum, it says. Well, how are the heaters done? How are the heaters done on these tubes? So we'll follow a heater back. Here's one, 6 volts. Well, of course it's 6 volts. It's a 6 volt tube. So grounded on one side, fed. Oh, look at this. See that? That's a. It looks like a. I don't know. It looks like. Is that an X? That's this. I think that's what this is. So the heaters are fed direct from the power. If I figured this out correctly. Heater. These are all heaters. And where else? Another heater down here. I think it's a 6 volt radio. So my heavy power supply basically goes down to 6 volts minimum, I think. But you can certainly put 6 volts, you know, obviously if you put 12 into here, you're going to put 12 right on the heaters. That's just not going to work. So it's got to be a 6 volt. Got to be a 6 volt deal. And if it is a 12 volt, which I don't think it is, then putting 6 volts on it won't hurt anything. And we want to see if this vibrator vibrates and if we're getting any high voltage here. Or if the radio just works. I just put the power on it. Okay. And positive, negative. Oh. Well, today all cars are, I believe, all cars are negative grounded. And the positive is the insulated part of the circuit. Any reason to think it's not the case here? What would it even matter? Would it even matter? Because you're coming in here, you're causing the vibrator to operate. It probably doesn't matter which way the DC goes through this coil. And then after that, you're creating fake AC. What does it matter what the polarity of the DC was? Yeah, it sounds like famous last words to me. These capacitors, are they marked at all? Is anybody got any kind of indication here? Yeah, we don't know what else is going on with the DC up here. It's coming up to the heaters. We don't know what they're doing with it. They could be doing something with it that I don't know anything about. And if I reverse the polarity, something terrible would happen. Okay, well, I'm going to stop for a bit. I'm going to look for some other resource to tell me which way. I'm sure there are something on the internet that will tell me, 1949 Buick, which way is the battery. I'm sure that information is easily available. So I'm going to stop for a bit, look for that, get some reassurance, and then we're going to try firing this radio up. Oh, that's a bad word. Fire it up. Okay, I think I found my second or some proof that it's negative ground. If we just look at the vibrator here, you can see it says right on it, 6 volt negative ground. This looks like this doesn't look like an original. by any means. The antique automobile radio. No. Solid state. Oh, 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 oh. Okay, I'm just, I'm pretty sure the owner of this radio told me these things when he handed it to me, but okay, solid state. Well, that's interesting because this piece here was visible in the photograph of the other radio. Well, I don't know. Maybe what they've done is they took I don't know what they've done. I won't even guess. Okay, well, we're reassured. Negative ground, 6 volts. Okay, I think we're really getting close to doing it here. Now I got to figure out how to connect a 6 volt supply. Like I said before, it's going to draw a fair bit of current, so we can't just use a clip lead here. We got to do something more certain. So I may in the end have to solder some wires on, like I can solder back here to get a good connection. Now what's inside here? Well, darkness is inside there. I don't know if I can. I don't know what's in there. So I have a few connectors like this guy, but he's way too big. And this guy's way too small. Okay, I keep looking for something I can plug in there because that would be very convenient. We'll see. So I did actually find a plug I can shove in here, but it doesn't feel like it's sliding into anything. It's hitting something at the end there. I wonder if this isn't a threaded deal. Something goes in there and then it's turned in tight. So I think I will do the solder a wire to the back here. We'll bring it out. And that should actually be a wire that goes all the way to the power supply. That's really what I should do. Avoid having a joint in it. Okay, now I'll figure that out. Okay, so I've picked up a piece of heavy lamp cord because I know the current's going to be heavy. I've mounted, just soldered this, so it's a little warm. 2 plugs to go into the power supply over yonder. And now I'm getting ready to solder the wire onto the radio here. Okay, so pull these apart. The positive one is the one with the ribs. It's this one here. A little awkward getting down in there to solder it. And the ground one, I'm going to want this to come probably to here. Tough soldering it there even. Or is there a better spot? Spot there. Right in here, this would be tough too because of the amount of metal involved. Or right here. How about right there? Look at this. It's a nice little hole there. Yeah, if I just solder that there. Now, what did I do the right one? Yes. Okay, I can solder that there, and this guy, let me solder that one right now. Even this might be a little tough. Tough to heat up all this. Looks good. I'm not going to touch that for a minute. Now this guy in behind here. So I chose to use connectors on the other end. I want to use connectors on one end or the other so I can unplug the supply completely from the power supply to get a visible point of isolation, as opposed to relying on switches to turn the power off. Because we have hands. Hands can touch switches, and switches can be turned on. So if I use plugs and I unplug the wire, I cannot accidentally energize this. That's what it's all about. Very good. Okay, I'm feeling pretty good about this. So the problem with the radio, I assume always with car radios, is going to be the vibrator. But having seen the vibrator is now a electronic one, it probably is not a problem at all. So before plugging this in, I'm going to go take a little break, just ponder the situation a little bit instead of rushing ahead and getting into trouble here. Okay, we're all set to go, and I've got a meter here that we can measure the DC voltage. We want it to be around 6 volts. So on the 10 volt scale, 6 is up about here. So the meter comes up in this area, thumbs up. I want to make sure the radio is switched off to start with. Do not want it coming on. So who's the on-off switch? That's got to be the on-off switch. You hear me clicking it. Okay. So this is basically, first thing we're doing here is we're basically testing the power supply to make sure it's producing the voltage I think it's going to produce, which is a little over 6, I imagine. Okay, so this is off. We'll set the at the bottom. There we go. Turning on the power supply here. There we go. Does the meter go backwards? Is that what just happened? So I almost never use this meter, so maybe I've just got it set wrong. DC 10. How come you look like that? Oh my gosh, it's going the other way. Okay, so these leads are incorrectly. The red is in the positive. How can this be backwards? It's not supposed to happen. Well, yeah, over there on the actual meter on the power supply says 6 volts or so. The battery's gone dead in here? No, there shouldn't be any batteries for this. What the heck? What the heck's going on? Bring out another meter. I like using these meters with the pointers on them. I find that just mentally a little easier to follow than trying to read actual numbers. So that's what we're going to do here. So, what do you say? Okay, so maybe I've got a bad clip lead. Yeah, onto the black lead, Jim. What do you say? Bad clip lead. Is that really possible? Oh, it's possible. Because I did not check them before I started. Let's check them. This guy looks pretty good. No. Bad contact. Yeah, just bad contact. Nothing wrong with that clip lead. So if I connected this to a short circuit by accident without knowing it, this ammeter would have shot way up, and I'd know it right away, but it did not. So I'm not concerned leaving this doing what it's doing right now. Yeah, checking the clip lead here. She's perfectly fine, I think. There's nothing wrong with this clip lead. What would it be? Think, man, what are you doing that's dumb? What are you doing that's dumb? Let's read right on the end of the wire here. Got too many voltmeter leads. Reading with this voltmeter here. So there we are. Beautiful. 5.7 volts. Why didn't I see that with the other meter? So close, and yet so far. Okay, let's try it just with the leads. Ground. Positive. What happened to you, meter? Wow, that's disappointing. You know what? This has batteries in it. I wonder if the if I left it on without realizing it. Okay, this meter's got to go for service. Yeah. We will rely on the digital one. How disappointing. So that blast meter has active circuits in it. It has an amplifier in it, and is a sort of a transistorized version of a vacuum tube voltmeter. So what it kind of is. I guess this is to some degree too, but no, not really. So we're on 6 volts. That's not enough. Put it on 60 volts. Checking in. What do we see? We see the whole schmozzle there. Okay, let's clip them on, because I'm going to keep an eye on this voltage. Even though it's really the current that this set is going to draw that's of great interest. But at first, I'm not so interested in that. Let's clip this on here. Don't want anything to go wrong. Cause a short circuit. Because my power supply has lots of protection in it, so nothing terribly bad would happen. Onto the ground. Let's just go right here. There we see the voltage. Good. Okay. Every step of the way. Well, you know, vintage shop, vintage equipment, vintage guy. I'm liable to get sidetracked here and there dealing with equipment problems and the like. Put this away. Okay, we've reached the point now. I can't delay any longer. .7 should be good enough to start. What can happen? Okay, I'm going to throw the switch. The radio has no antenna connected to it at all. So what can happen? You can end up being fooled and thinking the radio's not working when it's just suffering from lack of antenna. Okay, I'm going to solve the antenna thing before we turn it on. Oh, I see one channel on my recording might have been out there for a bit. Okay, talking about vintage stuff. Okay, this is my box of antenna goodies here. Antenna goodies. And here's one right here. That should be in a radio. And I think I've got... What have I got here? I've got this weird... That's the opposite of what I'm looking for. There's another. Where did I get these from? That's interesting stuff. That's not what I'm looking for. I'm looking for this. Here we are. Antenna connection. Wait a minute. Where's the... Wow. Wire. Look at this cable. It's actually hollow. And the wire on the center conductor is actually just flopping around inside that plastic tube. That's a little different. Have I got another one of these? Because it's a little hard to clip on antennas. pins. Another opposite connector. I don't think so. I think that's all I got in there. Okay. We'll make do with that. I think I have another one somewhere. Okay. We got, I left these funny guys out here. What in God's name would you ever want with those? Okay. Can I clip on that? Wow. I think I have to cut this back a little bit. Expose the wire that's inside. Don't cut the wire. You can probably hear the cooling fan running on the power supply over there, in case you're wondering what you're hearing. And you might even hear, if your stereo is really good, you might hear my furnace running right now too. I'm going to cut that center wire. There we are. Okay, so now I can plug this in here. Okay, I'm going to bring a lead over. I'll be connecting this to a fairly decent outdoor antenna. It should produce a good strong signal for the radio to chew on. Okay, I can put that like that. This is, okay, now, oh, it's kind of hanging out there. There we are. I think I got everything covered now. All bases are covered, so good time to go have a little coffee break. I'm just going to show you a couple of photographs of what's going on in my neighbor's house. If I look out my kitchen window, that's my neighbor's house, out my kitchen window, across my deck, empty deck with a bit of snow on it, and his, you can see the scaffolding there? So that's going up today. It's the middle of January, and there's a snowstorm coming. Scaffolding going up today. There's the guy putting it up. There he is. Well, if somebody told me, hey, January is a good time to repair your chimney, I would have said, no it isn't. But there he is, he's out there doing it. Wow, one guy all alone doing all. He raised that whole scaffold himself. I watched him. Obviously he's done this a lot too. You can tell he really knows what he's doing. Just thought you'd get a kick out of seeing that. Okay, I think I'm ready to try this out. I just want to get it on camera. It may be hard for you to see it anyway. This meter right over here is going to show the current drop. Just put that like that. And very hard for you to see it, but it's there. How did this guy start glowing? My expectation is the current's going to be high for the first moment. The cold heaters are going to draw a lot of current. But a moment later, it should be down to I don't know what. Well, let's see what's on that scale there. The scale is so dark I can't see it over there. Here, let's do it like that. Okay, so straight up is 10 amps on that meter. So if you can see the pointer, if I go straight up, we're drawing 10 amps. That would sound like too much to me, but I don't really know. Okay, I think we're ready. So I'm going to spin this around. Make sure everything stays connected. We don't short out those leads. Because that power supply can pack a wallop. I think it can do 30 amps. And can we tip this back this way? A little bit. Okay, so on off, gotta be volume, probably tone right here. This would be tuning, yes, definitely. And then there's something in behind here too, but I think it's all one shaft. All one shaft. I guess it's probably a good idea. So stand back for this. Okay, my eye is on that ammeter over there. Here we go. Watching the voltmeter and the ammeter, really. That sounded like the overload indicator, but the current draw, according to the meter, was nothing. Now I do have the voltage set right at the bottom on the power supply. Let's set it up a little bit. Okay. Ooh, that's a little too high. Okay, just over 6 volts on the meter now. It's not much different. This radio's drawing too much power for my poor little power supply to keep up with it. That's a little hard to believe. Let's give it another shot here. And keep my eye on that voltage too. Voltage dropped to nothing. Voltage went right to 0. And the power supply is indicating an overload. It only occurs when I turn the switch on, so it's something, beyond the switch. Oh my gosh. This might be as far as I get today, right to this point. Why would it show a short? Because I totally misinterpreted the power supply situation here. I've done something completely wrong. I just don't think so. So for instance, I could have reversed the polarity. Okay, let's just double check and make absolutely sure I did, because I have a way of doing that. I don't know if you do, but I have a way. So there's no question the ribbed part of the wire is the red side. Black is smooth. There's just no question. Black is smooth. And yeah, definitely. I definitely feel the rib side. There's just no question about that. The situation. What would you do next? You pull this out, I think would be the next thing to do. Pull out this guy. Easier said than done. Just grip. Cut your fingers off. Here it comes. Okay, this is not meant to come out easily. Ooh. That doesn't sound good. Oh my gosh. Oh boy, oh boy. Solid state vibrator 6 volt. What they've done is they banged this down to seal it. That doesn't sound good. That just, what could have happened inside this that would cause it to be like that? Inside here is just some electronic parts, nothing that should rattle around like that. Doesn't get blown to smithereens in there. Now, can I operate the radio with this pulled out? Again, my experience is limited, so let's look at the schematic and see if we can sort that out. So I pulled this guy out. So if we're applying power here, it's coming along, assuming the short isn't this away. If the short is this away, we got a capacitor here to ground, it could be it. We have coil, transformer, all this stuff. There could be some kind of short circuit inside here. If we pull this out, we are so the vibrator action. The vibrator. Well, this is really kind of yeah. I don't fully get this, but here's the primary circuit. We pull this out. There's no connection to the primary leads at all. And this connection continues to the ground here, but it won't go anywhere from there because this is out. That'll be the end of it. This will come along, reach this coil, it won't go anywhere. So I pull this out. If we still see a short circuit, then the problem is here, and it's a bad scene. That's a bad scene, I think. Let's try it out. Okay, so we're still supplying power. I'm going to turn the radio on. The power supply chirps away again. I think we had a big problem here in this radio. Here we go. Okay, so there was a sudden rush of current. You didn't see the current meter. Current meter is sitting about, I don't know, a couple amps. It went up to almost 10. Voltage is normal. So I'm going to turn it off. Not wise me to operate. This guy's blown to smithereens. That's what it is. He's blown to smithereens. We can't go any further until something's done with this. So this will be the end of the video for now. What I'll do is I'll communicate with the owner of the radio. I'll tell him what the situation is, and I'll ask him if I can bust this guy open, look inside it, because it's a little bit damaging. Trying to bend all this back is going to be an ugly result. But I think we got to see what's going on inside here. So that's it for today. Oh, let me turn this power supply off before I do something dumb. There. Big fat capacitor inside that power supply. So as it drains out, it'll send the alarm. It'll ring the alarm briefly. Very good. Okay, we got somewhere. Not exactly where I wanted to get to, but we got somewhere. So thanks a lot for watching. Tomorrow I'm guessing I'll be taking that apart. Watch. Come on, meter. Come on, power supply. Well, maybe it's not going to chirp. Oh! That's the goodbye chirp. Yeah, we'll take this apart and find out what's going on inside. Great. Okay, fiddling around now. I'll see you on the next video. Bye.